Yeah, can you tell me? So what it says is, in a first price sealed bid auction, it would be optimal, the Nash equilibrium would involve both the players bidding exactly half their valuation. So what it says is, in a Nash equilibrium, right, both players would essentially bid half their valuation. So if I value that car at 50,000, I would actually bid 25,000. Right? Yeah? Why do you think that's the result? Because bidding low is beneficial for me. Right? The lower I bid, the greater is my payoff if I win the bid. But the lower I bid, the less likely I am to win the bid. The higher I bid, the more likely I am to win the bid. But the higher I bid, less is the payoff from winning the bid. So as a tension between, so there is one pressure on the one side which says you must bid higher, the other pressure which says you must bid lower. And what ends up as is bidding at the midpoint, right? You bid half your valuation. Right? So obviously the person who values it more still wins it. The person who values the commodity more still wins it, but the optimal bid, he would still have bid only half his valuation. Right? So it is not possible in a first price sealed bid auction for the auctioneer to take away the entire consumer surplus by making the bidder bid exactly his valuation. See, this is a very, very important point, because a lack of understanding on this point can create several issues. For example, I am auctioning spectrum, and if a company which wins this spectrum is going to win a business of say 50,000, that does not mean that the company will bid 50,000. In a first price sealed bid auction, the company will only bid half its valuation. Right? That does not mean, then it does not mean that there is obviously any corruption in the system, where people are winning bids which value the, and who win the commodities and then make a lot more money from them. That is the nature of the bid. Right? So notional losses on spectrum perhaps should not be confounded with what one needs to look at is the Nash equilibrium auction conducted properly? Right? Was there any side deals happening with anybody? Right? Did anybody deviate from the spirit of a properly designed first price sealed bid auction, rather than did the people who win the auction actually get more money than what they paid for the auction? Because that is the necessary outcome here. Right? Sure? So when you value auctions, therefore, it's important. The story again is going to be then, what happens if I have other kind of bids? So suppose I am a bidder, I am an auctioneer, and I want to maximize my returns. So are there any other rules? So first price sealed bid auction could be one rule. There are other rules called the second price sealed bid auction. That is not the highest bidder who wins the auction, but the second highest bidder who wins the auction. By changing these rules, can I get something more? Right? And so ultimately, it's a question of how I design the rules of the auction. Right? How I design the rules of the auction. Okay? Right? And those are going to be some important areas that I'm going to look at. But an important learning today from the auction theory is, from the basic first price sealed bid, the commonest kind of auctions. Commonest kind of auctions is that the auction values that will be realized will generally be far lower, will generally be 50% lower than the actual valuation that the winner puts on the commodity, and that is the Nash equilibrium of the game. There cannot be any other solution. Right? Okay? We are going to now think of something very important. We are going to think of another important result that will come in. Actually, I can design different rules of the auctions, but we are going to show in the end that all the rules of the auction essentially give the auctioneer the same revenue, which is called revenue equivalence between different types of auctions. Right? So some amount of time we are going to devote our ideas of Bayesian Nash equilibria to understanding those kind of auctions. Then we'll think of online auctions and things like that happen on eBay and other things, and what do they really mean for your valuation? Are they efficient? etc., etc. Right? So those kind of things we are going to study when we study more of this literature after you come back from the long break that all of you are going to have. Right? Do you have any more questions? Any questions on this? No? Is this absolutely clear?
Yes.
Now suppose I said that one of the players is risk averse. तो क्या करेंगे? One player is risk averse. How will the situation change? Let's think of this. What does risk aversion mean? What does risk aversion mean? When do you say a player is risk averse? When the certainty equivalence of a risky outcome is less than the expected value of that outcome, then that person is a risk averse person. Right? So if you want to include one of the persons a risk averse person, what do you do? The person will probably not try to maximize the expected value of the auction, but its certainty equivalence. Right? And then the payoff function would change. So think of how the payoff function will change. Or do your own research, find out a little bit about what happens, how do you model risk aversion in a simple two-person first price sealed bid auction. Because that's how you actually want to think about the real world. We have looked at a very special case where both the agents are disputed. And we have looked at situations where we only looked at linear strategies in the Nash equilibrium. So if you allow for general strategies, what happens? Right? That's partly given in this book. Right? How to think of generalized strategies, right? With some inverse functions and all that. So that's something that we should look at. You, all of you have given this book, but the risk aversion is not there in Gibbon's book. So try to find out what happens if you actually want to model people as risk averse people, as most people would be. Right? Where do you think there are applications of this? Can you think of more applications of this? Where do you think this bit of information that you learned today would be important? Fine, think of it. Right, we'll meet you in the next class. Sure. How much time do we have?